So the recording stopped. There's some power issues. All right. So see, tokens, as I taught, was your smallest individual element of the unit of a program, and we were having some 5 tokens, kind of. You can say as these are the 5 types which comprised of a token. So it is keywords, identifiers, punctuators, literals, and operators. All right. So what are the keywords, guys? The keywords were the predefined words with a very special meaning to the language of compiler or interpreter. These can be same. The definition of a compiler, of a keyword, in case of a compiler and an interpreter would be the same. That is, these are predefined word with special meaning to the language. That's all. Okay. So we did yesterday as kind of an import. Sorry, I import the. My mic is on or not? Okay. So my mic was off. Fine. So we did as import the keyword, okay, and then we just drawn out it as keyword dot kw list. Now, if you don't know the programming, or if you don't know the code exactly of how to write or how to see all the keywords, now Python has an advantage of that you can work it at like help, and then you can write it for your keywords. Let's say keywords. So if you write for the keywords, what will say? It will bring all the keywords you are having there in your particular Python, right? That is your false, none, and comprised of all the keywords in a kind of a matrix I was talking about, a row, just a table of that, or the column and rows over there. So you can see all these things, right? So this is just of how you can just write help of your keywords, and you will get all these. Now, if you want it to be printed in a kind of a list, you need to write some codes. So if you don't know the codes, if you don't know these code, that is I have written here. So if you don't know these code, what you will write? You'll again go for the help, and there you will be writing for the keyword. So in place of s, I will only use keyword now. So now it will give me just a random just description of the keyword library, and it will also give me a link over for the module reference to work on that. Okay, so we'll click on this and we'll directly go to the official page of the Python library sites. There you will go to see the keyword HTML. So this stands for that keyword is a kind of .py library, and there you can see the is keyword will return true if s is a Python keyword. The kw list will contain a sequence containing of all the keywords defined for the interpreter and so on. So your code should be is keyword or keyword.kw list. Understood? So you can directly go there and you can access the codes from there also, right? If you don't know, that is very basic to go and access those. So let's write the code, and there you will be seeing a list of keywords over there. Now you can use print also to come off all these things. Okay, so these are the kind of a keywords. And now what are the identifiers, guys? Identifiers are the name which are given to the different parts of a program. Let it be for the variables, let it be for the objects or classes or functions. Like I said in this particular, let's say take an example. Let's say for x in a range of uh, 0 to 5. So for x in a range of 0 to 5, what we'll do is we'll see what are identifiers. So identifiers here is nothing but your okay, there is for, so this is for x in range of 0 to 5. Identifiers your variables. So what is a variable here? This is x. So this would be your identifier here. Understood? And here if I write it as print x, so again I have used an identifier. This is called as your identifier. Understood? This x, if I write it as, I'll highlight it something. Okay. So if we highlight it with the, not with the code, with the markdown. Yes. So if we highlight this one, so you'll see that these are my identifiers, not the ending first. So you might now know what is an identifier. You can see, okay, just give me a gap over there. So you can see for these x, there is some problems. The sprint of code, this is not code, just move these things. So let's So just remove this, you will understand this how it is. So these X is called as your literals, sorry, identifiers. Those are variables, objects, or can be classes or functions or lists, or maybe sometimes you can say as dictionaries. Okay, so these are your identifiers. So variables having some particular type of naming, you might be knowing, right? That variables must have only a non-keyword, right? Variable must be a non-keyword, and it must not have any spaces with them. Variable names must be made up of only letters or underscores there, and also it should not have a number beginning in the variable. Like we can't start any number like something like this 2 and then number and so on. Okay, we can write it like a number of 2, that is probably good, but we can't write it as a 2 number. Okay, you can also write its number underscore of 2. These are some of the basic, you might be knowing all these things. So suppose if I write the some of the identifiers, so I would be writing it as like, these can be my identifiers. If I write the examples of the identifiers, these can be the identifiers like my file or anything, date underscore 9 underscore 77, sorry, 77, anything. So if you want my file, these can be identified by, because these are nothing but the just a kind of a variable name. So now I'll be assigning these values. I can write it for 1, 2, and 3, and so on. That's all. Now if I find to print all these things, it will print me the value of that. If I mean to find all these, I will be seeing the value that is 1, 2, and 3 over there, right? Where it is on. Yeah. So this is just a kind of a identifier, you can say that. Now coming up to the literals. Literals or values are the data items that have a fixed and a constant value. There we have string literals, we have numeric literals, we have boolean literals, special literal, and these are the kind of a literals for you. Okay, so these literals, what do? These are a fixed data items with some very fixed or constant values. So in the string literal, what comes is just a literal which is a sequence of characteristics or characters surrounded by the single quotes or double quotes. If we come up to the string, what is a string actually? So it's nothing but anything, you can say anything comprises of coming under the single quotes or double quotes. That is comprised of a string. Now that can be a single line string, that can be a multi-line strings. Single line strings are comprised of like this is a single line string. So this is a single line string. If you want a multi-line string, what you will do, you will use 3 quotes over there, and you'll write like this is a multi-line strings, right? These are a multi-line strings you will be getting in like this. Slash n stands for the multi-line. Like we have a lot of things which stand for some other things, like I'll telling you those. So if I put a print over here and just put a here, so I'll be seeing this is a multi-line strings. These are the very basic things, right guys? So moving up, so as I said, we have an escape sequence of that. Okay, so escape sequence is something where we use the backslash and all these things with just a, so escape sequence is named as, so these are called as your escape sequence, right? So in this escape sequence, what you do, you just use a backslash or like a n value or so on, right? So here, let's say we have used the backslash, we have written it like a backslash over there, right? Now, if we write for the 2 1, what this stands for? This stands for your, let me write it as your markdown, that will be better for you. Alright, so it comes here escape sequence, and let's write for one single. So the single one with a, let's take first 2. So the first 2 will stand you for a backslash and its work will be to just use a backslash over there. Okay, So the escape sequence is double 2. If you want an escape sequence of that, so what you'll do is you will be using a backslash. Okay. Now to get a single quote, get a single quote, what you will do is you will be using this. Okay. This will give you a single quote. This will give you a single quote. Okay. This is how. So there are a lot of things which define for all of them. If I take it as, let's say, is, so these are the basics you might have done in your Python starting, right? When you were reading Python, you might have seen that this stands for a backslash. This similarly stands for a single quote. Similarly, we have a lot of things. We have just a slash and dash for a double quote. Similarly, A for your ASCII bells for us. Okay, you have B for your ASCII backspace. Hold on, just a minute. Yes. So similarly, there are a lot of things to cover. Now let's come up to the numbers of the Python. So in the numbers section, we all know that we have 3 type or 4 type of numbers in the Python, right? We have a kind of an integer, we have float, we have complex, and we have random numbers, right? You might be knowing all these things, right? So what are the integer? Every whole number which is comprised of, if you say every whole number which is not having any decimal or any, you can say, as fractional values, these are a kind of your integers, right? So any number which is not having any kind of decimal values is said to be your integer. What about the float then? So every number including the zero, in integer also you can include the zero. So every number including the fractional or the decimal values with the zero are termed to be your float, right? So that's a major difference between an integer and a float. Many times students get confused with that. Okay, so that is very interesting. Now let's see what is the integer. So okay, let's take it as integer. So what I said, integer is every positive or negative number with non or without decimal values. Okay, without decimal. So let it be. I'm not writing for the fractional because decimal also fractional also stand for the decimal ones. So we get the every positive and negative numbers with the decimals there, right? So this is the case of an integer. So what's the case of a float now there? So for a float, all right, let it be, okay, let it be capital F. The float is equals to, so why it was coming green? Because these are the functions for you, okay, and you should not use that. So that is why we are not using those things. Now coming up to the float, so let's copy these and just paste it with removal of your without. Here we'll copy here with no will not be there. So without will not be there. With will be there. That's all. So float is every positive and negative with decimal. Understood? That every positive and negative with decimal will term be as your float, and without it will term as your integer. That's very correct. Now when we come to the complex type, see in the complex type what happens, you might have read in the class 11 also the complex numbers. These are a combination of a real and imaginary numbers, right? So in the complex numbers you have two parts. One is your real part and another is your, you can say as your imaginary part, right? So in complex, when you come there, so complex is something we write it is a combination of, I'm not going to the bookish language guys, okay, so just a practical thing. So it's a combo of a real plus an imaginary part. Okay, so that's there we get just a real and an imaginary. That's the only thing we get in the complex, right? So we'll see when we'll work on the complex type. We'll see how we make it. Let it be capital C for that. Okay. Now these are the things, right? So these are the very basic 3 important things coming up there. Now, so now if you want to get an integer, what you will do is, let's suppose take an assignment operators of ABC and we'll just give it their name 1, 2, and 5 point. Let it be 5J and 2.2. Because you guys are familiar with the Python, I'm not going to take it one by one manually, just taking it a time for that. Okay, so let's cancel. So you have assigned A, B, and C as 1, 2.2, 5.0. Now you know about the typecasting, what it happens there, right? So see, in the complex, what I say, let suppose C is my complex number now, 5J, right? Now, if I want to see that is a complex number is having some real part and some of the imaginary parts, we all know, right? Now, if I want to see the real part of these, what I'll do is, if the real part of these, I want to see the real part of a complex number, what I'll do? That is your C dot real. So the real part of the C is 0.0 and the imaginary part of the C is 5.0. Now how does this comes? Let's say x equals to 25.6j, right? Because the complex number are a category falling inside A plus Bj. So we have 25.6j. Or let's say x, let's make x as 25.6 plus 8j. Okay, let's x be such like. So if you get to see the x real part and the imaginary part, what we'll see there, that, okay, let's have it, it's capital X there, imaginary part. So it says that 25.6 is the real part and the 8.0 is the imaginary part. So your real and imaginary will always be coming inside your float, right? So the typecasting is something like you change the castings, you change the data types of your numbers particularly. Let's say we want an integer of 45.2, so basically it's 45. So if we want to see a float of, let's say 25, we will be getting a 25.0. Similarly, a complex of any particular type, let's say 45, so you'll be getting 45 plus 0j. If you satisfy any of the thing, if you write as say complex of, so what about if you write a complex of, so you get a 5j as it is. Okay, these are the basic things which will come inside the types of your integer, float, and the complex. Now moving up, we come to see the random number. What is a random number? How these functions work on the random, right? So for the random, what you do is you just import a random number, that is import random. So import random, then you work with some of the modules of the random. So the random is having some things, that is your random of choice, random expovariate, you have random get state, you have the random range, random, and there are random and lot of things are there. Okay, so how to get the help from the random? Again, what you do is you just get on the help, and if you don't know anything about the random, just type of the random and you will be getting a help of the random. So it says a library of random. Again, you are just on the official page of the random, and then you can work for all the random functions, you can get it on. Okay, so these are the things you can see how these works, what are the random normal variate, what is log normal variate, and all these things. Okay, they're informing all the formulas over there. So these are the things which we get there, right? Moving ahead. So here we get to all of these things. Now if you see to work with the random, instead of just working with the random range, instead of working or importing, okay, let me zoom, instead of importing the random module, what I'll do is I'll just write that from the random I need to import only the rand range. So that depends from the random what you want to import. Okay, right? So from the random, what you want to import is the same thing, right? So what we'll do is now from random import range, or either if you import the random. What is the difference between all these? See, the difference between these is that if you import random, every library of the random will be imported. And if you write from random import rand range, then if you don't write this one, what will happen? You can only use the function of rand range. Then you can't use the function of the rand end or choices or any other thing. Okay, so that's the difference. If you, because many a times you will be seeing, I will be using like from, instead of importing the whole, when we see the data science, we will work on the sklearn library. So there I'll not writing that I will want the whole sklearn there. I'll be writing there from the sklearn and then something like import or something. Okay, so because importing a whole library will take a lot of time to work on. Okay, that is not a good thing to just import everything. Okay, but many a times when you want only limited things, that's not needed to import the whole library. That will just take a memory of that file and this will make it big. So to reduce memory, just avoid taking everything from your library. Just work with the limited thing you are working now. So I need to work for the rand range. So how rand range works here? See guys, in the rand range, what happens in the range, you guys are aware of that, all these things. So I'm not going much deeper. So in the range, what happens? You have 0, 54, or let's say 3. So what does this mean? Basically, you want the number starting from the 0 till the 53 with the intervals of 3. That's it, right? So if you go, you will be getting the range of 0, 54 and 3. That's it, right? So it's very easy. Let's say if you are writing for the 6, you will be getting it in the intervals of the 6, right? These are the things that you should be focused on. So if I take a rand range, see, rand range plays a very important role in all the companies for getting all the OTPs of the several, just a password or something like that, right? So what you do there is, if I write just, if I say that x is equals to, if I write a rand range of any particular number, let's say for 45 to 90, so I'll be getting some random numbers, right? I'll be getting again the random numbers and all these things every time a new number. So what will do that? The companies how we use is just they define a code, something like, let's say your code is a rand range of some numbers. Take any number, let it be 1, 2, 3, 4, 5, 6, ending 9, 8, 7, 6, 5, 4, any particular number. Okay. Then you just print a line over there that is will be, let's say for the Google one. So you have its str, and str of you have the codes, and then you write it like is your one time, or let it be one time Google verification code. Okay, this is V. So it's verification code one time. So this is how it runs on, and you just leave a gap there and you run this. So you get it something like that. This is your one time Google verification code, isn't it guys? You see like that, right? So this is a particular use of a random range, you can say on. Okay, you can also print it like, you can also just print the same with like this. Let me copy these. So these are some of the practical uses of the function modules you use. So there maybe you can also get it like, or it's not str. Let it be moving up all these. Let's write code, comma is your so this is your Facebook password reset code. This is like something you will be getting. So this is your, let's remove these spaces over there. So this is your password Facebook password reset code. This is how you get from the random ones, right? These are the basics you can just go on. Yeah, next moving ahead to, we have a type called as strings. So in strings we have a lot of things. So in the core data types, if we see, we have numbers, none, sequence and mappings. Okay, for the core data types, what I said, that you have sequence, you have numbers, you have none, you have mappings. Now how are those interpolated? Let's say it can be plotted as Don't go with the code what I'm writing now. Just understand the file I will writing. So I'm saying that let's make a core data type. So the core data type particularly comprises of four major things. What are the four major things? It comprises of a number, okay, what is the error? Okay, it comprises of a number where you have three major things, like you can say it has your integer, it has your float, it has your complex. Understood? You have three there, and in the integer itself you have one more type. Okay, in the integer itself you have one more type that is called as your boolean. So then we have two major types, boolean and integer. You can say integer is of two types. You can write it off like integer and the boolean, integer and the boolean for one particular type. Second, the numbers, and the numbers would be probably a list of your this list and then float and the complex. Okay, right? Then we come to see the another thing that is, as I said, it's a kind of a none. None. So none would have an empty list. Nothing would be there. In the none would be an empty, no key value. So you would be writing similarly the none here. Alright. Next. When we have sequence, so in the sequences we have kind of a string, we have their list, we have their tuples, right? We have all these things there. Okay, moving on. And the last we get there is your mapping. So in mapping you get to see the dictionary. So particularly what I have done is a dictionary there. I am doing a mapping over there. Okay, this is your dictionary done. Let's see, no errors. I think there should not be any error. Pandas has been imported. So if you see your core data type, so it will say the number is having these things, none is having. So what are my core data type numbers? If I want to see my core data type, and I want to see what are the numbers there. So I am having integer, boolean, float and complex. So let's see if I make a data frame of all these. So there might be some arrays must be of same length. So there are 1, 2, 3, 4. Yep, data, that would be a probability of not a kind of a thing there. So what we'll do is it says the to the of the same kind, same, just the length should be same because we are not having the length same, so it's a problem for that. So we have here of your two types, we use the non having no particular value. Let's say NA for that. Let's go with this again, and there's a problem with these. Alright, there's no issues. Alright, we will see the things later. So now we got to see that in the number we have integer, boolean, float and complex. If we find to see for a none, particularly in a none we have NA, that is your not a number, or and sometimes we write it as NaN, that is not a number. Okay, these are some of the things which is comprisely stand for your the combination of your core data types, right? Then so these are the core data types of it. Now we have some of the mutable and immutable types of the objects, right? So what are the mutable type of objects which can be changed or which can be indexed and which we can edit on for, okay? So and what about the immutable? So immutable are those which can never change their values in the places, right? For changing all those, what do? You do a lot of procedures for making them, right? So we have mutable. Mutable means, or the topic of mutability means that in the same memory address, new value can be stored as, and when you want the new data types, you can allot there, or new variables you can allot there, right? So those are a kind of your mutable and the immutable. Then we have expressions which are called as the valid combination of your operators or literals, or let it be for the variables, right? We have all those things. Yeah. Now we have the arithmetic operators and or a lot of operators we have, right? So how many operators we have? Anyone can let me know here how many operators we have? Yes, that might be used to you, right? So how many operators we have? Yes, anyone will going to say? You have rectal functions. I saw there many one. Sorry, you are not audible still. It's 12:22, 54. I think I'm audible now. So yes, I'll ask to what is his name? Harita. Let me see what is his name then. Harita. So she's saying that 20 operators. Yes, can you let me know the 20 operators name? Yeah. Say what are the operator names? Quickly, anyone there? How many operators? If yes, then how many operators? Write down the name. Giving one of example, just one example. Chaitra is saying arithmetic, correct? One is arithmetic. Okay, let me ask to. Okay, I can see now the relational, assignment, logical. Okay, we have four now. Yes. What comparison? Yes. Okay. Anything at bitwise, correct? One is missing identity. Okay, fine. So yes, that's very correct. So if you go to see the operators, I taught in the morning to them. So we have these much operators there. We have arithmetic operators. So operators are the tokens that trigger some computation or actions which when applied to the variables, right? So we have arithmetic operators where we have plus, minus, division, integer division, the multiplication, the modulus. Okay, one left there. That was an exponentiation. So assignment we have these all things. Okay. Uh, these are your assignment operators. Okay, sorry, by mistake I have written assignment. It would be comparison one. Sorry, these are your assignment. This is not an assignment one. So this will be bitwise operators. This is your shift operator, identity operator, logical relational operators, and logical operators, and the membership operators. Okay, these are the things we deal with the number of operators. Spell check, yes, spell check is, yeah, spell check. Assignment spelling is error, and the sometimes there are operator spelling also there. See this one. So this can be operators. A assignment would be there, and any more again here. there might be some places for the operators. These are the things. Okay, so we have read about that. So there are a lot of arithmeters, operators, and you know the functions still are making you just okay. Now we'll be doing the questions also. Okay, I'll giving you the question and you will have to solve and answer right now. We'll see how much Python you know. Right. So moving ahead, let's take a question over there and let's take just a very common question. Okay, fine. So let the question would be, my question for you is very just a quick and easy question. Let's say I have A, B, C, D, E, and F, and I have the values as 4, 5, 2, 5J, 0, and 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yes, now I have all these values for it. Now, my question is to find you the A plus B whole square. Okay, this is your first question, right? Find A plus B whole square. Using the arithmetic operators, you can write it very easily too, right? And you meanwhile find the type of D divided by, find the type for D divided by F. Just do this quickly, these two, and let me know the answers. Yes, waiting for your answers, guys. You might have solved. So what is the code if I want to find the A plus B whole square in the Python? Yeah, quickly, anyone there? 81 is the value. It's how to find complex. If I need to find A plus B, what is A plus B? It's 4 plus 5. So okay, yes. So Divya is saying A plus B. Exactly correct. This is the step what we are learning. Okay, so these are the operators. Fine. So what about the type of D by F? What is the type you are getting? Complex. What is the kind of that you are getting there? Let's say for that I'm checking. So this is my square and my type so it is 81 and complex, obviously correct, right? Okay, so I believe you guys are good at arithmetic operators. Okay, so yes, now we have some modules we'll be using because in data science we'll be doing a lot of statistics parts, right? So statistics includes the maths module. So are you guys compatible with the math? Do you know the math module? Anyone who knows math module? All right, no problem. See, so the math module basically, or the math library, is a standard Python library that provides a module name as math, and it gives you the relations or the functions which we use in the mathematics. Okay, so that it could help you. So for that you can also get for the help of the math. I think you will be getting there. So you can see now the reference of the library mathematics, and you will be straight get ahead to the math. You'll find everything math.c, copy sign, fabs, factorial, floors, fmod, frep, and the exam. In the Microsoft examination, trust me guys, you will be having a question. What is the uh, value if we want to find the absolute value of a number? What is with the math module? What are the options? So there you will be getting the options of math.ceil, math.fabs, math.floor, math.mod, math.frexp. These 5 values will be there. So you'll have to select the correct one from there. Okay. So that's why I'm saying the modules are very important to learn on. So this is a C math module, and you get what math.ceil does. It return the ceiling of an x, the smallest integer greater than or equal to x. If x is not a float, delegates to x.ceil, and then you get something. So let me tell you all these. See, so you can write it something as your maths, import maths. Then you get to import maths. Now you can directly write what module you want. If you want math dot log or something like that. So there are a lot of things to explore in maths. So the first is your ceil. So the maths dot ceil will return the smallest integer not less than the number. Understood? The math dot ceil will return you the number or the integer, the smallest integer which is not less than the number. So if we take it with the example of let's say the prototype, we write it as is the general form. So let's first understand what math.ceil does. These are a part of things which will be using in the data science, because there you'll be having some statistics, and you need to find some of the radians, sine, cos, flow, right? All these things. So let's write off for math dot. Let's take it as a math dot ceil of the first. Alright. So when you come to math dot ceil, so what is there? The methods. So their method is that the ceil function returns the smallest integer not less than the number. So if you write math dot ceil of some any particular number, let it be 1 or 1.5435, anything. So what happens there? If I write math dot ceil, and if I give it from 1.03, so what the statement says that you will be getting 2, right? The smallest integer, but not less than the number. Alright. So every module will have, you should have to remember what you are getting there, because in the examination when you will be asked, you will be given not 4 options, you will be given some 5 to 6 options. So there you will be kind of a bit confused, and it will not ask you for only one correct option, it will ask you for more than one correct also. Sometimes in this question it will ask for you 2 options for, okay, there you can see it's fabs and floor are the correct answers there. Okay, I have said one answer for your question. There fabs and floor over there. Moving ahead, yeah. So math.ceil, what it does, again I am saying, the function will return you the smallest integer but not less than the number. Okay, so 1.013, the smallest number is what? Is 2, right? The smallest number from the 1.03, the smallest integer what you get, it's 2. It will not give you the less from the number, so you will be probably getting the 2, right? So next come up, you can also check it for if you write ceil of minus 1.03. So what it will give you, guys, what is the smallest integer from the minus 1.03? Say, just say right here. Yes, I'm waiting for your answer. But what will be the smallest integer? 1. Harita is saying 1. No, 1 is exactly wrong. Minus 1, Yukta is correct. So see, minus 1.03 is nearest one is minus 1, right? Why it would be 1 there? It will be not less than the number, right? So you will be getting minus 1 there. Understood? So the nearest integer, see the, or you can say the smallest integer. So the smallest integer is the minus 1. Okay, right. Then we come to the next module of saying as this as your let's say it's a kind of 4. So this is your maths.sqrt. So what this sqrt, as the name we can find that it will give you the square root. Okay, so this sqrt function will return you the square root of the numbers. So if the number is greater than 0, so the domain error occurs there. Okay, so if the number is less than the 0, it will just give you a domain error. So let's find out. So if I write math.sqrt, and if I say that the maths.sqrt of 81, so what's the square root of 81? It's obviously it's 9.0, right? So if I take a maths dot sqrt. What if I take a square root of minus 81? So it says a math domain error. That was I'm saying. If a number is less than 0, it will say you a -1 into typo. What is saying? Okay. So you will be getting a maths just a domain error out there. So you need to give some positive values. So that depends on whatever you write. It will be 125. So its square root is something like that. Okay. So this is your description of that. So next, moving up to the next prototype for the maths of exp. Okay. Now that's of particular natural logarithm. So if I write it as 4 and it is taken sometimes as the argument. Now see, so in these case what you do, you take a number there, right, and in this case you take an argument there. So the exp function will return the natural logarithm e raised to the argument power whatever you write, right. It will give you a natural logarithm of e raised to the power whatever you will be writing in the place of arg, right. So if I write it as maths dot exp and let's write 2.0, so to give an output of e to the power of 2.0. Understood? Basically e to the power of 2, that's all. Understood? So if I run this, you will be getting a value of that. So if you want to see the value of e, so there you will be getting 0 something like that. Okay, math dot exponential values, will be doing it again in the below one. Now moving up to next one, what is about the fabs? So this is an option you will be getting in the examination. What is fabs? Now here also you need to write a number over there. So math of fabs. So this fabs, what it does, it will return you the absolute value of a number. That's it. Okay, and your question will come in the exam exactly that what is the absolute, if what is the method, what are the methods to find out the absolute value of a number. So you will be using fabs out there, right? So if you write it as maths.fabs of the number, and let's say maths.fabs, and if I take it as 1.0, so what it will return? The absolute value is 1.0. So if I take it maths.fab of the number 1.5, or it will be minus 1.5. So what will be the absolute value? It's 1.5. Now the question will ask you which math module will return an integer value of the absolute value. Okay, that will be just a messy question for you. We'll deal with those things. Okay, so we got math.fab that is 1.5. So these things makes this as an absolute, but not as a float. If you write in float, we are getting in float answer. Okay, so make focus. The question will ask that if you write a float there, what is the math module which will return the absolute value but in the integer, not in the float? That will be the question. Okay. Moving ahead. So next we come up with the floor one. So in the floor also you take a number over there, right? So there comes, if you see the floor also returns the largest integer, not the greater than the number, right? Understood? It will return you the largest integer, not the greater than the number you are writing. Largest integer, but not the greater than the number. How? Let's take, you are writing math dot floor. So if you are taking off 1, you will be getting 1. Same. But in case you are using the floor 1.03, still you will be getting 1. So it will return you the largest number but not greater than the number. Understood? Largest integer value but not greater than the number, whether positive. So if you write math dot float minus 25.25, so you'll be getting minus 26. So in case of minus 25, what will be that? It's minus 26. Okay, that is not greater than the number. Understood? That is not greater than the number there. Moving ahead. So this is the function of a float. So if I write a math dot float of let's say minus 2.0, so you'll be getting the minus 2 over there. This is how it works. You will not get the greater number, but the largest least number from the number over there. Let's go. So for the next one, we have as a logarithmic value, or you can say as a log of that. So we can write it as a log of a number. That can depend on what number you are writing, but you should also give the base over there. You should also write the base of that. So the log of a number of a base particularly. So this log function returns the natural logarithmic value of a number, whatever the number you will be writing. So a domain error will come only if the number is negative and if the range error occurs if the argument is 0. So what to be needed here to keep in the mind that if you write any number less than the 0, you will get a domain error as you got in the square root, and if you write any number there which will be out of a range, will be getting the argument as a 0, right? So if you write the number as a 0, logarithmic value of a 0, so there you will be getting something. Let's see what comes. So let's say you are writing the math dot log of 1.0. So it gives the natural logarithmic value for 1.0. That is your 0.0 exactly. So if I write math dot log of some number, let's say 1024 by 2, this is a base. So it will return you the logarithmic value of 1024 to the base of 2. So this would be the value. If I write the log of, so this would be 1, right? So log of 10 to the power 10, it's very easy, right? You know what is something like log of all these things. What do you do there? It's just nothing but a log of 10 to the base of 10. That's it. These are your base, and this is your log. Okay, moving on. Yes. Then we come to see the next one as a log 10. There we have so what about the log 10? So log 10 will return the base 10 logarithmic for the number. Understand? So that will return you the base 10 logarithmic for the number. Okay. So the log will give you the natural logarithmic value, and this will give you the base 10 value. Okay, automatically. It will not require any base to be written out. It will just give to the base 10 power. Okay. So similarly, if you write the log, or if you write of log of 10, log 10 stands for you are using the base of the 10, and then you write the 10, so you'll be getting of 1.0. Only if you write math dot log of 10, if you write it for, let's say, 1024, again you will be getting it as the base of 10, 1024 to the base of 10. Okay, this is how you get that. Moving ahead, the next one you have, it's for maths dot power, right? Maths dot power. So what power does, you know, right? What power does exponentiation of all these things? So we'll write it as your maths dot power. So it's POW, basically POW. of some particular number, then you give the power. So it can be written as your maths dot. So what it will return you guys? So it will return you the base raised to the power of exponentiation, whatever you will be writing. Okay, sorry, I forgot the exponentiation here. Exp. So it will give you the exponent value what you are writing for. Okay, so it's base or maths dot power, and then you write the value where it is. Okay, so then you write the value of the power whatever you want. Let's say you want the value. So you guys know that anything to the power of 0 is equals to 1. So if you write it as anything to the power, let's say 3.0 to the power of 0. So what you will get there, 3.0 to the power of 0 is 1, right? So if we write it as maths dot power and 3 to the power of 2, so it's 9. This is how it works. Just a common example for that. Okay. So now you might be familiar with the sine graph, cos graph, and all these things. So if you want a sine graph, you will be using math.sine, or any sine value, you will be using math.sine. So this sine function will return the sign of the number what you will be writing on. Okay, and the value you will be getting in, you would be just giving the input should be in the radians. Okay, so if I write sine 90 in radians, what is that? So okay, there. So sine 90 in radians is expected. So sine 90 degree. Like that. If you in the not radians, let's take in the degree. Let's take a degree or radians table there. Yes, that's exactly. So here we come up, one of the image might be having all those things. Yes. So see, there you have degree, you have radians, and you have gradients too. So we can go with all these things. Now let's take the sign of the argument, whatever you want. So if I write it like maths dot sign, and then I give just a value, whatever you want. So like I will give 45. So I'll be getting a value something like that. Right. So this depends on the math sign. Similarly, you go with the cos also. The same function, you will be getting the cos value. As if you use math dot cos of, so getting these things. These are the basics. You can similarly got for the just of the tan. Now to find any degree into the radians, what you will do is you similarly let's find out for the tan also, and then change the values to the degrees and all these things. Let's say I'm on a tan of 45, so it's 1.61 something. That's good. Now see, if I don't know how to convert a degree to a radian or a radian to a degree, like I did, normally people will do that. It will go to internet and then search for all these. So it's a better option not to go there. Okay. So what you will do then? You will use the functions of your degrees and the radians. So there you get to see the degrees, or particularly x. So the degree of x will stand for the number you will be giving. Okay, so it will convert the angle from the radians to the degrees. So let's say you are taking first, let's say a degree, first take a radian there. So radians will be making from the radians to the degree, converting an angle from a degree to a radian. So let's take it whether I am writing for the maths dot radians. Alright, then I'm taking a radian, or I'm taking a radian as let's take it as 60 or whatever we have done till now. Let's take it as 45. So it says 0.8537, or let's take these values. So we get this. So basically what happens, you convert whether if I let me take it as math.radians, and then I'm taking, okay, let me write here. So if I write a radian of 179.9, so I'll be getting the value as 3.14. Alright. Now if I take a radian of, okay, not radian now, let's see for the degrees. So in the degrees, what happens when you write math dot degrees of, let's say we have written for 3.14. So 3.14 is my degree, and I want it to be the radian, so you're getting the same value, that is 179 on that. So now if I write it as math dot degrees of 60.0, so I'll get a radian of these. So if I use NP, sorry, not NP, if I use math dot sine of 3437 dot 74, so I'll get that the sign of that is 0, something like this. If you will get that as kind of a 0, so you can get the maths that radians of 60, so it is 1 point all these things 1.04. so if you see maths dot sine of 1.04, so you'll get it 0.82, something like that. You can interconvert all these things and then can do a bit of mathematics without using any higher library. There's nothing, just a bit of easy thing for mathematics. So there are some of the things with you can work with the math, and then you can write for the function name, and then it will just work on, right? So these are some of the things we have deal with the basics of the mathematics. Okay. So now let's get to some of the extent of the operators questions, right? I think you might know for the questions over there, right? So we'll discuss a bit of more interesting things. So did you guys ever learn this math? Anyone who learned it before? He or she might would have get just recalled everything. Okay, I think no one from there. All right. So no need to worry. So next we saw that we were having some kind of statements for flow and control or all these things. So what is exactly a statement control, or what is flow control statements? So first of all, we'll see what are conditional statements or what are loop over there. So see, and a program statements may be executed very sequentially or selectively or iteratively. Okay, so every programming language, like a Python, every programming language, it provides you a construction to support the sequence or the selection or the iteration, you can say, right? So maybe a conditional, you can say, is a kind of a statement or set which is executed on the basis of a result of a condition. Okay, a loop is a statement which will be a kind of a set which is executed repeatedly for a number of times. You need to iterate it, and it will number of times, like it kind of, you know that how much number of times you want to repeat, or until the condition becomes true, or until the specific condition is required or met there, it will be keep on iterating. These are the kind of loops, right? So the compound statement we have is the kind of a three statements, that is a compound statement, a simple statement, and an empty statement, right? So what exactly a compound statement does? The compound statement your represents a group of statement which was executed as a unit. Okay, so the compound statement of Python can be written in a specific pattern, like let's say let me write it as for compound statement. Alright, so a compound, anyone who has read these compound statements? Maybe 1.25. What maybe Yukta is saying something, or maybe. Alright, so compound statements. So you can see there are a lot of things. I have not used every of them. There are factorial, there are f of REXP, there are f of sum, f of GCD, you have is close. A lot of things are there to see whether a math, how these things are used on to is finite or not. There are a lot of things. I have not taken every of them. So you can get explored by just writing help of parenthesis in the mathematics, and then you can just go on. So yes, we were in the compound statement. So see, compound statement, you can write it as you can just write as a compound statement header. You can just give a compound statement header for that. And there, then you can write as this kind of intended body, right? So this is a kind of compound body you get, compound statement you get. So it can have multiple or simple compound numbers. How you get to that is like, this is exactly a statement how you get to it. Okay, this is a just you will get an invalid syntax, because this is a kind of, you write a compound statement. Now for that, what you do there, let's say example of a number. Let's take, you have written number 1, let it be any number 1. Okay, let me ask a very interesting and very basic question. Okay guys, let me know, if I take any input from the user, what is the data type I am getting while the input? Yes, the first one who will answer will be the winner. So the Diksha is saying STR. Okay, Diksha is saying the first one. What about the rest? STR. Yes, string. Right. So whenever you take an input from a user, you take by default as a string. That is to be kept in mind. Okay, these are some of the things you can be asked anytime, anywhere. Okay, basic things. So let's take an input, and I'm defining is the number. So I'll take it as an integer. Enter a number to there. So we'll get number. Let's take number 2. So there you'll be having some integer, and again you'll be having an input of, let's say, so the kind of enter a number, and it's all for the two kind of numbers you have got. So once, see, these are the two statements I've done. Now we'll try to see what are the compound statements. The compound statement is something where you will be giving some of the statements inside one particular statement to the conditions or the loops of the compound statement. Okay, so there what we'll do is, now let's see, if I write, if the number 1 is less than the number 2, so we'll say that, or let's say number 2. If it is so on, so we'll write t is equals to num1, and then, or let's say number 1 multiplied number. If number 1 is less, right? So number 1 is less, then what we can do is number 2 is, number 1 is multiplied by number 1. That's it. Okay. And then we'll do just an addition. Normal thing, I'm just giving any just roughly structures of the data. So there we can do with this, and then we can go for print, and then you can just write on then what is your number 2 and what is your number 1 and as well as what is your t. These are the things. So what you did here is exactly you just take a line inside which you took another line that is called as your compound statement body. Okay, that's very easy. So this colon at the end of the header line means that it is a compound statement. Okay, and this contained statement, this particular box within if are intended to the right side. These are the indentations you say, the gaps. Okay, so we'll print this and we'll see enter number. Let's take it's 5 and 10. So we see 5, 10 and 35. What is this though? So number 2 is your 10, number 1 is your 5 and t is your 35. How is it number 1 into number 1 which is 5 into 5, that is your 25 plus 10 gives you 35. That is all. Okay. So these is a kind of a compound statement guys, right? So next we come up to see what are simple statements. So simple statement you can say the compound statement which are made up of a very simple statements. Now any single executable statement you can say like this one statement is a kind of a single statement, right? So any single statement which is executable are called as a single statement or yeah, that's all. Okay. So what is an empty statement? So the simplest statement is a kind of an empty statement, right? So that you can say is a statement which does have nothing or a statement which does nothing, okay, which do not work at all, just as a kind of a statement as you can say as a kind of a empty statement. Suppose if we see now an empty statement is a pass. Pass is a kind of an empty statement, sorry, double S. So this is a kind of a empty statement. It takes from the following, and whenever you just in the Python when it counters a pass statement, Python does not or do anything and moves to the next statement. Suppose if I write it as x is equals to 12, and if I write pass 10, pass x equals to 10, and then I've written x plus equals to 25, 24, 23. So there is some error. Yes, so the pass one is error there. So see, you can get in help for the pass and you can understand how it does on. So there's. So the pass is a null operation. You can see when it is executed, nothing happens. It is useful for a placeholder when a statement is required syntactically, but no code needs to be executed. For example, right? In that second def of pass function of that nothing does. It's class of C, class with no things of. Okay. These are the things of the pass statement. Meanwhile, if you want to check, you can directly do as something like, let's say, remove the random and go for the pass. Let's see. Okay, it's not there because library. This is not a library over there. This is just a null. So nothing is there for the pass. That's right. So yeah. So these are the stated as your empty statements. Okay. And sometimes pass comes over there. People or students have a lot of confusions. What exactly pass? They think that pass is a very big command to work on. What in the sessions, the previous sessions I had till now. In the 11th, 12th, I took a session at ISC Bangalore. So their student came, and on the first day, 4 to 5 were having doubt, sir, what is pass? So before starting the session, they just asked, sir, what is pass? How pass work? So every time in every workshop, there is some students are there who ask around for the pass for more than 1 to 2 times. So pass is nothing. There's a kind of an empty statement. But since it's a workshop, we'll not to deal with all of these things. Just we go with the, suppose if you are attending a workshop there and it's compared to the training, what happens? There I'll be discussing what is log 10, that's all, completed, maths module completed, next moving on. So this is how it works because we have a shortage of time there. And now here we have a 40-hour session, a lot of the time, so we'll be using very smoothly, okay. So now next we come to the conditional statements of an if and else and all these things. So what is this if conditionals? So if conditional of a Python come in multiple forms, like it can come in a plain if form or it can come in a if else form. So if else is called as your if elif, okay. So plain if statement, what it does, if statement just tests a particular condition, and then if the condition is evaluates to be true, a course of action, or just then whatever the code you are writing, it will be followed up, and the statement of set of codes is executed. That's all how the if works are. So if you write the syntax of the, okay, let me write as conditions, or the if. So let's take the if conditionals. So the if conditionals, there you have, as I said, three types. So the syntax of the body would be kind of if, and then you take the condition. The conditional statement of the body. Right. Once you have the statement, or you can write as not the statement exactly. It's kind of an expression. So once you are done with your expression, you give a colon over there, and then you search, or you just write for the statement, and then you execute these statements over there. These are done there, right? So these happens and come as an output to you. So there, let's say, okay, these are the syntax exactly what you've done there. So let's see, convert on there. And now let's say if I'm taking if A is, or if my grade, let's take a grade from input from a user. So I'll take an grade input. So he will enter a grade, and then I'll check that if the grade or is equals to coming the range of A to A or A, something like that. You can search for that. If the grade is coming between A okay, so let's say we have only grade A and B. So if this is grade A, so I'll just print it as congratulations. That's all. This is how it works. So if I take grade F, nothing has been done. So if I take grade A, so it says congratulations, or either if I use grade A, so it says okay, there's some problem. The A ones might be equals to the spaces. You can do anything. Let's remove the spaces over there, and then you can test for that. Okay, done. So you can see it's coming with the capital A or small a, we get the congratulations message from that. This is how the if works, right? This very simple thing. Now the else if condition will test your a condition and will evaluate true when only if the conditions comes true. So it comes like, let's say, first your this statement will be checked out, this particular one. So let's copy these. First this will be checked out. So and then your else will come there. Then the else will again having some of the statements and then their execution. That's all. This will run as category as your if does. So in the else one, you will be checking with these things. Okay. The if and else particularly. Similarly, you have elif and all these things. So okay. So we'll go in the just in fast forward of the if else, because these are the things you do every day. So let's say a number. something is missing. Yes. So if the number is less than 0, what you'll do is, depends on you, whatever you write. Then let's see that if the number greater than 10, we'll be printing on the single digit number is entered. Alright, similarly you will be doing for all that. So LF number is greater than 10, or you can write as equals to 10. So you will be taking double digit number, and so on. You can just go on for writing. So these are the conditions. So if the number is equals to, number is less than, okay, let it be less than. So if the number is, you can say less than 100, so it would be a 2-digit number. So you can remove this one. It's of no worth. So if a number is less than 100, that would be a 2-digit number, and if it is less than 999, it is less than or equals to, you can write and so on. You can use it, right? So these are the just the basics of all the things. You can meanwhile also use the else if it coming there. So you can also use else as this part. So else will not check any of the conditions. It will just print out. You guys know about that because you have used Python, so that's good. If you run this, it will ask for any number. If I take any number, let's say a single number, enter, let's say 79, so it's a 3-digit number. And if you run for the 45, so it's a 2-digit number. So let's take any number, minus 87, so it says an invalid entry. So a valid range is 0 to 999, and so that you can run out, right? So these are some of the things. So there we can also have some nested if and else and all these things, right? In the what is do in the nested if and else, let's say that we are having the same as x, y, and z. What do you do in the nested x? Let's say this is an x. Similarly, you are having this as for y, and similarly to for the z. So what I'm doing here, so I have x, y, and the z now. Now what I'll do is, I've taken the input. Now I'll be using my nested if else. So in the nested if else, what happen? A if or else is encrypted, or you can say inscribed in the one particular if. Okay. So if we write it as, let's write it as your mean is equals to the max, is equals to the median, and the meanwhile you can write it as mean of that. So mean is, let it be mean is equals to the max now here. Okay, so number, you can assign the numbers in the median order. Okay, So that mean is not working in the Python 3 for now. So we'll assign for these things to be none now. Mid is not working, I think. Let it be max and mean to be none for now. That is your 0 now. Okay. Now I'll check now my x is, if my x is less than y and my x is greater than or less than z. So in this state what I'll do is I'll be just using another if else, that is if my y is less than z, I'll be saying that the minimum and the maximum would be the x and z. Okay, so this will be the minimum maximum value. So now if it is not so, so I'll be doing the else. So if it is not so, then what would be there? The minimum and maximum value will be x and y. So minimum and maximum value will be the x and y. Let me give just a separation, otherwise you'll be confused for that. Now you can understand it better. Similarly, I'll checking for the elif. So the elif x is less than x and your y is less than z, will be coming up with the another statement. Let's say here we'll check that now if the x is less than z, if x is less than z, then the minimum and the maximum value of the x and z would be probably like y. If the okay, we have taken the x and z, right? So we'll write the minimum and the maximum value as y comma z. And if it is not so, let's take another thing. So if it is not so, then we'll write down that our minimum and maximum value. What will be there then if it is not y and z? Probably it would be z comma y. Right? It would be your z and y. It would be your y and, sorry, not that. It would be y and x over there. So these is your if and else. So if it is not so, what we'll do? We'll go in the else one. So that is very okay. That is a kind of easy steps, but just a bit of confusion will be there. So if we see x is less than y, so there we'll go to find that the mean and the maximum. The minimum and the maximum value for now would be the, let's say, z comma y. And if it is not so, we'll come to find the mean and the maximum value, the minimum and the maximum value of the numbers would be then the z and the x. So I think that's okay. I think no thing to just go on. So if we consider all these now, so you might be seeing that now you have if x is less than y and x is less than z, then we'll see whether y is less than z or not. If it is so, then the maximum, minimum and the maximum value would be something like that, and all these things happen. And at last of all these comparison, after comparing all these things, what we'll do is we'll print the numbers in the ascending order is equals to the minimum and the maximum. So it says 5, let's take 5, let's take minus 4, let's take 2. So we didn't find any of the minimum and the maximum. Alright. there should be the minimum and the maximum come in there. So might be because of the functions. So let's take it as I've stated it none there. It's okay. Then coming up in the else part is completed over. What is the problem of that? So 2 and 5 is there. Where what about the 4 has where 4 has gone? There is some mistakes, right? I think there are some of the mistakes there. Anyone who can find out the mistake? No, not there. So x is less than y and y is less than x. So that's right. X then and y is less than x. X x is x and the y. And only y in x we find it as the y in z line and the maximum z. So x is z and y maximum needs to be z and x. The number you are printing will be the minimum number and the maximum number. So yes, these will be the minimum and maximum number. Meanwhile, I can also assign the mid one. Let's assign the minimum mid number also. So the mid would be the x comma y comma z. The mix would be the x comma z comma y. Here the minimum median number would be y comma z. Set comma x. So there in the beginning. Like probably this would be fine, I think. Would run. Alright, so we get the ascending order and so on, right? So this is how we just do the nested if you aren't assigning the mid value. Yes, there I forgot for that the mid one. So mid has been assigned, right? This is how we work on like this. So these are the method of the nested if, okay? So similarly, we store of the some positions, we store some values over there. We have looping statements and all those things to deal with, right? So I think you would be clear to be some extent today. So I'll be giving you the assignments today, and that would be kind of so first very simple assignment I'll be giving to you. So there would be that will be the Python assignments of the very simple one. So you know the first program string operations. We didn't discuss the string today, so we'll discuss the string tomorrow. So there, see, you just have to go. Okay, how do you check the Python version of the system you are using? Okay, this question is. You can do it with the usage of the if you write it as help of. So this can be done using the help of the SYS system. So this is system specific parameters and function. So you have all these things with the help of a SYS you can do. You can search for, okay. So there what you can do is just you can import the sys and then you can write sys dot and there you have a lot of versions, a lot of methods. So you want the version. So that's all you got the version. Sure. And you can get your more thing apart from that. You can also get the version info of that. So these are some of the questions I'll be giving to you. The basic question and just solve what so that you can have a basic practice of this. Okay, so just let me stop your video.